calendars we put in our wall, from the books that we read, and even this watch. There is math.
Hi everyone, my object here is a chessboard and it is unarguable that chess is all about mathematics. The chessboard itself follows a certain pattern, which are the squares here and the set of numbers on the borders. Also, the analysis of positions or where to move has a lot in common with solving mathematical problems. Chess is a matter of correlation. It is to decide what piece is best to move at a certain point. So if you have logic and mathematical reasoning, then surely you can beat anyone in the game of chess.
People use math knowledge when cooking. For example, it is very common to use a half or double of a recipe. In this case, people use proportions and ratios to make correct calculations for each ingredient. If the recipe calls for 2/3 of a cup of flour, the cook has to calculate how much is half or double of 2/3 of a cup. Then the cook has to represent the amount using standard measures used in baking such as 1/4 cup, 1/3 cup, 1/2 cup, or 1 cup. So use a 1/3 of a cup and fill it twice if you don't own or can't find your own 2/3 measuring cup.
Today, let's talk about Fibonacci sequence. Fibonacci sequence usually appears everywhere because it models physical reality since we see it in spiral patterns of various objects. For example, this egg naturally resembles a spiral and approaches the golden ratio. Furthermore, the Fibonacci sequence is a set of numbers that starts with a 1 or 0 and proceeds based on a row that each number, a Fibonacci number, is equal to the sum of the two numbers before it.
Mathematics in nature. Everywhere we go, we see objects related to math, whether it in the form of pattern, sequence, or symmetries. Let's take, for example, this turtle. When turtles are looked at closely, one can observe that the entire shell is made from individual subunits and that its pattern resembles the shape of a hexagon. The surface of a turtle shell is covered in a bony geometrical shapes called scutes that are packed tightly together. The scutes in the center of the shell are hexagons. These are surrounded by a ring of pentagons and irregular shapes. Turtle shells are formed in this shape because hexagons can effectively cover closed surfaces with minimal material waste. Furthermore, the geometry of their shell keeps turtles from getting stuck on their back.
Now take this clock for example. Its hands move in perfect harmony thanks to the math of trigonometry. Trigonometry deals with the relationships between the angles and sides of triangles.
The hour and minute hands, for instance, are like the radii of a circle, and their positions are calculated using trigonometric functions. As time passes, these functions determine the precise angles they form. So every tick of the clock is a testament to the mathematical principles of trigonometry that keep our world running smoothly.